Hi, good day, everyone, and welcome back to the Sustainable Agriculture Workshop hosted by Andrew College. And today we have Dr. Cathy Day, who is a Climate Policy Coordinator at the National Sustainable Agriculture Coalition. Welcome, Dr. Day, and how are you?
Thank you very much. Thanks for having me here.
Oh, that's great. We always love to take some time and chat with the experts in the field, and especially to provide knowledge and information to our audience. So can you give us like a brief synopsis of exactly what do you do and with relation to agriculture and the institution you work for?
Yeah, so the National Sustainable Agriculture Coalition is a coalition of 130 groups around the country that work in food and agriculture. And so they work on all kinds of aspects of local and state level policy, but through us, they get to work on federal policy as well. And so my work is anything that relates to climate change, but especially conservation policy and research policy, and help to push at the federal level, both in Congress and in USDA, to get more climate-focused policies.
Yeah, I think that's very important because I always love to talk to climatologists about how agriculture can actually influence the climate and climate change, because agriculture is actually a major driving force in the climate change realm, and a lot of people don't understand that. So I'm glad there's an organization that's pushing for more money for research and pushing and being an advocate for climate change in agriculture. So let me ask you one question I'd like to ask you. First off is, like, what are the best options for sustainable ag, increasing food production while reducing its combination or its contribution to greenhouse gas emissions?
Yeah, that's a great question, and definitely one that I work on in a lot of the work that I do here at NSAC. And first of all, I think it's important to recognize that there are multiple challenges that we have to meet to repair the damage from industrial agriculture and industrial culture more broadly. So the very top of the list, along with climate change, is biodiversity. Those are both huge threats facing us right now. So both of those will leave us in pretty dire straits if we don't move to make agriculture and other elements of our culture directly ready to address those issues. So the key when it comes to agricultural transformation to deal with those issues is to think about holistic systems. So the more we shift agricultural ecosystems, or agroecosystems as we call them, to look and act like other intact ecosystems, the better off we're going to be in the future. So to think about what that might look like, first and foremost, I would say it means increasing biodiversity within those systems. And that's because intact ecosystems accomplish many jobs without the need for industrial inputs. So for example, the current agroecosystems often rely on fertilizer that has to come in from somewhere else onto the farm. Why does that matter? Well, fertilizer, especially nitrogen-based fertilizers, rely on a great deal of energy to produce, and much of it comes from fossil fuels, specifically from natural gas. So these fertilizers create high greenhouse gas emissions when they're produced, some emissions when they're transported, but most concerning in climate terms are the nitrous oxide emissions they create in a lot of conditions when they're out in the fields. So in fact, agricultural soils generate the majority of nitrous oxide emissions in the United States. And it's important to note that that is a particularly potent greenhouse gas. So if we think about that from that perspective, we want to think about all the problems created by fertilizers. We also can look at the fact that they decrease the health of the soil biome. So with herbicide use and other pesticide use, fertilizers tend to create soils that just rely more and more on fertilizers, but don't give a lot back to the plants and support plants by themselves. So instead, a more biodiversity kind of approach to agroecosystems reverses a lot of that damage if you give it enough time to work. So for example, if you give a farm 5 to 7 years, you get financial support for that farm and educational support for that farm, it can transition to a system that requires no off-farm fertilizers. So that might look like something like incorporating nitrogen-fixing plants into the farm system. It might be, for example, clovers and alfalfa and other legumes. And those can be relatively smoothly incorporated into existing large-scale tractor-dependent systems, if those are the systems we want to worry about the most. And cover crops are one version of moving in that direction. So you plant a crop between the cash crop, plant it to help recover the soils, to add nutrients, to build up organic matter. And then even better is when farms can build up systems of what the Natural Resources Conservation Service calls resource conserving crop rotations. So you build in a rotation on the ground all year long that covers a lot of those same goals, but keeps the soil covered all the time. So people might go out, for example, have a cover crop and take a machine called a roller crimper out and roll down that crop. And that's kind of going to crush it and get it to stay on the ground, and then come through with what's called a no-till drill that can plant seeds into those cover crops. And that no-till drill will allow crops to come up from in between the cover crop. And you end up getting all these benefits from the crop that is behind this cash crop you're trying to grow. It gets shade, it gets nutrients, it gets moisture, it gets cooler temperatures on the hot days and more even temperatures on the cooler days. And we as a society benefit because systems like this add more and more carbon in the form of organic matter into the soils. So by keeping those soils covered, the carbon will stay in the soil and in the plants instead of being released into the atmosphere. And then carefully managed soils where there's nitrogen are generally going to produce less nitrous oxide. So it also has a benefit for that particular greenhouse gas if you have some carefully managed resource conserving crop rotations. But I'd add there's a whole other set of systems that we often don't think about as agricultural systems, but are really central to getting some of these solutions on the ground. And that's the biodiverse kinds of ecosystems like agroforestry systems. So we combine trees, we combine shrubs with other elements of the agricultural system. So they might produce crops, they might produce shade or forage, or they might just block the flow of the wind. So the trees have a lot of different roles. And one of the things we've increasingly been learning from the archaeological work that folks have been doing and the historical work people have been doing and going back through the records is that a lot of pre-European North American agricultural landscapes look like agroforestry systems. They used to make a lot of use of tree crops, of shrub crops, but they probably didn't look like the tidy rows and groupings of single species that we often think of now. They were much more integrated systems. So maybe an area near your home, if you lived in the eastern forest, for example, would have included lots of nut trees and brambles and shrubs, and they all would have been mixed together and combined with herbaceous plants that provide leaves and roots and other kinds of foods. So that would have produced abundant food through a lot of the year. And then you add in hunting on top of that, which used to be people's most common source of animal protein. And you got this nice system that looks like an intact ecosystem, but is functioning to feed humans. And it's cycling nutrients. It doesn't require fertilizers. It has diverse insect populations, diverse animal populations. And along with that highly diverse mix of plants means you don't generally have pest problems because you don't get the concentration in plants.
Right.
So we start seeing folks now who are adopting systems like this. They're taking, more human management into the system instead of machine management, but it's better at sequestering carbon, at decreasing nitrous oxide emissions, encouraging water to infiltrate and remain in the soil, keep the soil in place, and it gives a lot of food per acre. So in the case of systems like the one on a farm called New Forest Farm in Southwest Wisconsin, they're building what very much resembles those pre-European systems, but instead of wild game, they have kind of traditional livestock in the system. But lots of trees, shrubs, herbaceous plants combined with their livestock. And so all of those systems bring ecosystem benefits, but if you've got something like nut tree crops, it also provides abundant storable crops. Just like grain offers us now, nut crops are immensely storable and lots of nutrition, and they can be made into flours that we can use for breads and all of that sort of thing. So in redesigning our agroecosystems, we really need to look to the local ecological conditions and understand what kind of systems they'll support, and understand how plants and animals already work together in those systems, but also draw inspiration from the way people have done things in the past and think about how those diverse systems like the acorn-centered systems of California, the grassland-centered systems, the bison and buffalo on the plains, or the systems further east that have as their tallest crop members things like chestnut and pecan and hickory. All of those systems can be part of our inspiration for the direction we go in the future. And if we're concerned about feeding everyone in systems like this. We just need to insist that these more integrated plant and animal systems start to function, and perhaps ask folks to eat a little less meat and a few more plant-centered meals every week.
Right.
You know, not get rid of meat, just not make it essential.
Right.
And
Just limited, yeah.
yeah, yeah. So if we put our industrial systems that put livestock into confined systems as the greatest source of agricultural greenhouse gas emissions, we know that that is really one of our big sources of emissions. The wet manure management system and the overabundance of cattle all are resulting in a lot of methane emissions. So that, along with the nitrous oxide emissions that come from the cropland, means that we have a lot of greenhouse gas emissions. But if we can move away from those confined animal systems to systems that integrate the animals back into the landscape, we get a food system as a whole that not only is reducing those emissions, but is also sequestering carbon dioxide in the soil.
Yeah, because I'm thinking you mentioned a lot of good information there. So, example, in my mind, I'm thinking that the system like permaculture, a large scale permaculture farm could do so much wonders. You have a mixture of everything. You have the agroforestry, you have the animals back on the grass, eating the grass, not on a natural environment and things like that. And most importantly, a lot of people don't understand that soil plays a major role in climate change and with respect to sustainable ag. A lot of farmers, where we are in Georgia here, we do a lot of conventional farming, right? So, we are heavy on the fertilizers, we're heavy on the pesticides and herbicides. But if you do like if you have a farm that's like large scale, like a permaculture farm, you really and truly don't need pesticide because you have a variety of crops, and pests don't really like a variety of plants because they can't eat everything inside. And then some plants might bring the predators for the pests too. So that's some really great points. I hope the audience really appreciate your knowledge in terms of climate change with respect to sustainable ag. So let me ask you. So what will be like the risk of mass migration arising from climate change, and how will this impact sustainable agriculture systems?
Yeah. So, my training is in geography, so that migration is something geographers focus on oftentimes. And so the first thing I think we need to understand about migration is that most of the time when people are migrating, it tends to be for economic and social reasons. They may migrate to be closer, for example, to better paying jobs or closer to family, or oftentimes for education. People often move when they go to college, for example. But disaster-related migration is usually a last resort when other means of dealing with adverse conditions fail to solve problems like a lack of access to resources. People's ties to home tend to be so strong. They tend to want to stay where they are and adapt as much as they can. So that migration is really a last resort. But that said, we certainly know that changes like sea level rise are going to affect where people are. We're certainly seeing that, for example, in North Carolina, where a lot of folks have farms that are now so close to the saltwater levels in the soil that they can't grow crops anymore. So they're having to make a transition. But if we look at more urgent, perhaps, situations, we look at islands in the South Pacific, like the Marshall Islands, that already are experiencing freshwater loss and eventual loss of their land. We've already seen people migrating because of those conditions. People have come from the Marshall Islands to the US. It has past status as part of the United States. So it's a place where people have the legal right to migrate to the United States. It's a place where US conducted a lot of nuclear tests. So it's part of the reason that they've ensured that there's a path for people to leave, because there's some guilt associated with that history. But those residents are coming to the United States already, and many of them have settled in Arkansas. And then within the US, if we look at migration, we may be able to point to some instances where people have already migrated. And I'll talk about that in a second. But Matt Hauer has modeled a bit of how residents of Florida, for example, as our most susceptible to sea level rise state, are likely to move, and a lot of them may move to other states like Texas or elsewhere in Florida. And when we consider a different impact, like wildfire, we've also already seen some people moving. So like California's Camp Fire was one example we keep really in mind, even though I think we've had equally bad fires since then. It was kind of the first fire where we saw just this huge loss of a whole town because people had to leave. And so those folks are ending up in some cases in other states as well. Now, what that means for agriculture, I think, is a lot more complicated and probably not that clear as yet. Certainly, we can speak to the fact that South Florida, for example, eventually we're going to lose that as an agricultural production zone. And a lot of things like tomatoes and strawberries are produced there in the winter. So that may change our landscape. But if we think about that model of trying to transform to more diverse agroecosystems, that's going to require more people to work in farming. So it may be possible that as people migrate, perhaps we'll be able to make some spaces for more people to be able to work in agricultural systems, and we can kind of build up those systems, be richer and more effective because we have more people in that space. But it would take a lot of resources and a lot of intention to do that right.
Yeah, exactly. It'll take a lot of resources, especially in terms of monetary resources as well. And that's something I personally think that the USDA needs to funnel more studies on that.
Absolutely, yeah.
Provide more grants to say, for scientists to actually do that. So that's something. If the USDA is listening, I hope you guys listen to what we're saying.
Absolutely.
So given the high current direct and indirect inputs into ag, how can food production be made carbon neutral to allow emissions to be met, to allow emissions targets to be met over the next 40 years? And do you think that sustainable ag can achieve this?
You broke up a little bit for me, but I think just in case folks didn't hear it, let me repeat it back in case it was not just on my end. So in my opinion, is sustainable agriculture helping to achieve this? That was the part that didn't quite come through.
Okay. So the question was, given the high direct and indirect, inputs into agriculture, especially sustainable ag, how can food production be made carbon neutral to allow emissions target to be met over the next 40 years? And I was wondering whether or not, what's your opinion on if sustainable ag can actually achieve this?
Okay, thank you. Thanks for repeating. I hope I'm not the only one who had that blank space. So to some degree, the things I've talked about already help to address this, but absolutely, I would say sustainable agriculture systems are doing a great job of addressing this on many farms that are using organic, the systems that you've mentioned, permaculture systems, or other kinds of agroecological principles to guide their work. So if they're thinking about perennial plants, if they're thinking about the diverse systems that we've talked about. So I think the question we have is not whether we have systems that can make this carbon sequestration happen and it can reduce greenhouse gas emissions, but it's a question really of how we can educate and support the vast majority of farmers who are not using that kind of systems to help build them up. And I think that's where we really have to start looking to things like the federal programs, as well as state programs that do similar things. But for example, the Conservation Stewardship Program pays farmers to maintain and build upon their systems and make them more and more sustainable. And there's state-funded programs doing similar things. Certainly California is a great example of that, but other states as well are doing a lot of that kind of work. And supporting farmers, I mentioned at the beginning that it takes kind of a 5 to 7 year time span to shift from doing very conventional systems, as we call them now, with a lot of fertilizers and pesticides, to those systems that are already so well integrated with plants and animals and everything that they don't need those external inputs. And so farmers need support during those years because sometimes they don't have the same yields during that transition time that they would have otherwise. And so a big piece of all of that is support financially as well as education. And that includes educating the next generation of farmers with ideas that are going to move us toward these kinds of systems instead of educating them in the very conventional kinds of agriculture.
And education is so very important. I mean, there are a lot of misinformation out there when it comes to sustainable ag. And I always believe that, as you mentioned, the younger generation definitely needs to be educated about sustainable ag, because I feel like the younger generation thinks agriculture is what they see on TV, more conventional, conventional types of farming. They're not really open to seeing what sustainable agriculture is all about. But as we mentioned, education. For example, what are some of the different ways or some of the different methodologies you're familiar with that how to put it in a simple manner? I'm trying to put it very, very simple for audience. How can we institute or how can we make long-term carbon sinks be placed on our farm, for example, or in our production system? What are some of the methodologies we could include to encourage that?
Yeah, yeah. So I think to tie in the education piece a little bit, part of that is just making sure that people know that that is an option, that they understand how to incorporate perennial crops into their systems, including trees and shrubs, that they understand how to work with those who are developing, for example, the perennial grain crops like Kernza that are out there. You know, the Land Institute has been working for a long time on these kinds of crops, and Kernza was the first to be commercialized, and it's not on a large scale yet, but there's some elements of it that people have been turning into cereals and beers and things. So it's starting to be something that's a real option. I think we also, as we're creating carbon sinks and thinking about the education piece, we need to put more funding behind the entities that support these kinds of education. So I'm thinking the Land Institute is an important one. The Savannah Institute is another. They work on agroforestry, but also the USDA entities like the National Agroforestry Center. They could use a lot more support, get on a lot more people, and they could help much more to scale up agroforestry, but they're right now a tiny little piece of USDA, and scaling them up would make a big difference because there's some really dedicated people who work there.
Yeah, I met a couple of people in that office. So again, I hope the USDA is listening.
Yes, absolutely.
So how can, for example, like how can the inclusion of agriculture and by extension sustainable ag in carbon markets provide significant benefits for farmers?
Yeah, that's a really big question. And that's one we have long struggled with here at NSAC. For us, we would say the answers to that are sort of unclear right now. And generally, the National Sustainable Agriculture Coalition does not tend to be a huge supporter of agricultural carbon markets. And that's because a few factors, but the history of carbon markets has been pretty poor for farmers generally. The benefits that are offered are rarely sufficient to really help farmers make the kind of transformational change they need to make. They're pretty low payment rates per acre. There are also concerns that it's simply an excuse for industry to keep emitting greenhouse gases, even while asking farmers to do the job of sequestering the carbon from those greenhouse gases. So it doesn't get us away from the fossil fuel use as effectively as we might like. And then for NSAC, one of the deepest concerns is that carbon markets are likely to exacerbate existing structural inequities in the system. So paying out a lot of funds to farmers who have large tracts of land so that the small acreage payments are worth a lot because there's so many acres, and not paying anything or much to those who have small or medium scale farms. And that includes the majority of farmers of color. So we see that as highly problematic and one of the elements of carbon markets that tends to make us push against them.
Okay, so that's pretty interesting because I'm getting the feeling that the carbon markets tend to what we call, underrepresented farmers. It kind of affects the underrepresented farmers. So that's actually a great point. So my other question would be like, so right now, what research what research are you involved in with respect to climatology and sustainable agriculture?
Yeah. So as I've moved into the policy role, I'm not doing research directly anymore. However, my past research has focused a lot on how farmers deal with climate change. So for example, I conducted research in Niger in West Africa to work with smallholders there and understand how climate, but also social and economic change were changing their ability to adapt to the system, because they have a lot of challenges. Some of their increasing challenges include drought caused by climate change that has gotten more severe, and at the same time, floods that have gotten more severe and that can wash out their crops. So it's a very strange dichotomy where they have big problems at both ends of the scale. But I've also worked with farmers in New Mexico and in Florida who are dealing with severe weather, who are experiencing social and economic impacts, and who are trying to transform their systems to more sustainable systems. And my last project was in Florida and very much focused on farmers who are really trying to shift their systems. And it was really inspiring to see a lot of what they're doing in order to, incorporate some of the things that we've talked about already in this interview.
Oh, that's great. That's great. I'm glad you're on that committee because you could push and be a very good advocate for civil agriculture. So I'm happy, we have more people like you out there advocating for this, especially with climate change. My last question to you though would be, anyone who's like young, like the student, because there might be a lot of students watching this interview. Students who are interested in sustainable ag, students who are interested in extension careers, or even, a career in policy like yourself. What advice would you give students in order to start their career?
Yeah. Well, I have to say that the experiences that I've had have been extremely helpful, and that part of what that has involved has been understanding the science of agriculture. So I've gotten a lot of experience with the natural science aspects of agriculture, and also understanding the social scientific pieces of agriculture. So sort of the sociology, the archaeology, the geography of how farmers are dealing with climate change and where they can go. So I really encourage folks to get a grounding in natural science, but also do some investigation of the social science elements of things, and definitely the policy, because people really don't understand a lot about policy outside of our little world. And
Right.
we need more good advocates who are pushing for better systems. So we'd love to see lots of people get on board with that.
That's great. That's great. Well, thank you very much, Dr. Dave, for spending this afternoon with us. A little bit of time is greatly appreciated. For the viewers, I hope policy is a whole different ball game now. As Dr. Day kind of alluded to some of the aspects of sustainable agriculture. So thank you very much, Dr. Day.
Thank you very much.
Thank you.